Generative AI is the hottest topic in our industry right now, and the fascinating set of tools and technologies that are in the forefront of that movement have only been around for a few months. I'm thrilled to introduce our next speakers that are at the forefront of this space. Tyler Hutcherson, a senior applied AI engineer at Redis, along with Harrison Chase, the CEO of LangChain. Tyler helped design and implement many of the vector database use cases we'll dive into currently, while Harrison leads one of the most popular frameworks for developing applications powered by language models. Tyler and Harrison, welcome.
All right, hello everyone. I am Tyler from Redis, and I want to welcome you to this exciting session on how Redis and LangChain can power your LLM applications in production. With me today, we have none other than Mr. LangChain himself, a man who truly needs no introduction, Harrison Chase. Harrison, thanks for being here today. How are you?
Tyler, thanks for having me. I'm doing well. I'm excited for this. Really excited to be here.
Awesome. Well, look, we all know you're insanely busy with the LangChain project, and we're going to obviously dig into that a little bit today, but we're pumped to have you with us. So for everyone watching today's session, we're going to start with a brief overview of the AI landscape. Then we're going to hear from Harrison himself about the LangChain project and simplifying application development. Next, I'm going to share a little bit about Redis features, some new ones and some old ones that lend itself well to being used in the modern AI sort of landscape. And lastly, we're going to round it out with some example use cases and code samples. And hopefully that sounds good to you all. We know many of you have been looking forward to this, so let's go ahead and dive in. So in discussing the best ways to try to succinctly explain what exactly is going on right now, we figured a picture is worth 1,000 words. So we pulled Google search trends on major topics like machine learning, deep learning, big data, and a quick peek at this chart here pretty much tells the story that the AI landscape has undergone a lot of transition, a lot of shifting in the last 20 years. And this is partially due to specialized hardware like GPUs and TPUs having improved efficiency of some of these models. And also the improved penetration of the internet and connected devices has created a large amount of data for us to take advantage of. And traditionally, before some of these AI approaches, we relied on handcrafted rules and logical reasoning, which, as you can imagine, were pretty complex and required a lot of effort to create and to maintain. But with the advancement of deep learning technology, as we discussed, these models can now learn on their own without human intervention. And so this is where all of this hardware, all of this technology advancement has finally moved AI from the research labs into the real world. And so ChatGPT and OpenAI, just as example here in this chart, have literally taken the world by storm. Many industries are adopting AI-powered solutions to improve their efficiency and accuracy and even decision-making. And many of you are probably using ChatGPT on the daily now for things like copy editing, brainstorming, research, maybe even life advice. But what's under the surface of all of this? So this is where generative AI, which is a branch of AI that involves leveraging powerful, what we call foundation models, to generate new data, such as images, music, text, or even videos, plays a role. And one of the big generative AI sort of topics is large language models, or LLMs for short. And so these language models are massive neural networks that have been trained on ridiculous amounts of text, data scoured from across the web, books, articles, web pages, encyclopedias, websites. And one of the most advanced pre-trained models is the Generative Pre-trained Transformer, or GPT. And this is the foundation of ChatGPT that we were just talking about. These large language models learn and can summarize text. They can do language translations. They can power chatbots or even generate new content. A new stack is emerging that consists of modern app development tools, and this is only a subset, as well as large language model providers. So LangChain, for example, is a framework for developing applications powered by language models, and it started as an open source project a few months ago, but has really taken off. Other major LLM providers like OpenAI, Cohere, Hugging Face are partnering with all the different cloud players to make this technology available to developers and enterprises. But despite all of this investment and this exciting activity, adopting the large language models in production is still quite a challenge. And so now for potentially the sobering part, a little bit of a buzzkill. There's clearly been a lot of investment here, but there's still some real concerns. And it all starts with cost. So self-hosting, or even worse, trying to train your own language model from scratch can be pretty costly. It's estimated somewhere around $100 million was spent trying to make the GPT-4 model that just came out from OpenAI. And so also using some of these fully managed services, like from OpenAI or Cohere or others, these repetitive or even unchecked API calls can rack up over time, especially at scale for enterprises. Another concern is with latency. LLMs are typically slow. These are, again, these massive neural networks, lots of computation happening under the hood, and especially for shared services, they can be unpredictable in terms of traffic load or even rate limits. And so lastly, most importantly for enterprises is quality and security. So we don't always have the best clarity regarding the specific data used to train and test and fine-tune these LLMs. And so this can impact the biases of these models themselves. And when presented with questions or unknown tasks, they often tend to confidently make things up, and we call this hallucinating. There are a number of factors here, but most pressing, the quality of the LLM and what data it has access to during training and inference has a huge impact on the enterprise-grade applications. And there are and will continue to be advancements along these lines, but this is the state of the union. So how can we set ourselves up for success? And this is where not all hope is lost, right? We have the right person in the room to help us get acquainted with one of the hottest and emerging libraries to help build and mitigate some of these concerns. So Harrison, I'm going to gladly hand this off to you. Please take it away.
Thanks, Tyler. And yeah, that's a great overview of the space, and I definitely don't think LangChain can help with all those issues. There's still a long way to go to get these in production, but I think there are a lot of things that LangChain can hopefully help with. And as you mentioned, it started off as an open source project that I was working on on the side. I was basically going to a bunch of meetups, chatting with a bunch of folks who were building stuff in the space, and this was even before ChatGPT. So this is way back in September and October of last year. And chatting with a bunch of folks and noticed some common abstractions in terms of what people were doing in order to start building applications on top of these models. The common abstractions in terms of the flows, but also in terms of the components. And so those are one of the core pieces of what's in LangChain today. All these different components are little like Lego building blocks, as well, as I like to call them. So you've got some, and these are the ones on the right, you've got some that we kind of just provide a standard interface for and kind of wrap and package up in a nice way. So the model wrappers, the vector store wrappers, some retrievers. We don't we're not producing language models ourselves. What we do is provide a nice standard interface for others to kind of interact with them. And these are all different components that you're probably going to need in some form or fashion for more complex applications. And that's really what we were focused on. And then the ones on the left in the components columns are ones that we actually have in-house and kind of have built out. And these are things that we saw a lot of people building the same version of things over and over again. And so we figured, you know what, might as well factor out some of the most common ones, put them in this library and kind of go from there. Besides these building blocks, we also have a lot of use case specific chains. And these are basically ways that we saw people combining these building blocks to achieve certain kind of tasks. So we saw a lot of people doing question answering over their own data, which we'll talk about a lot more later. We saw a lot of people interacting with tabular data, interacting with APIs, doing evaluation with language models, extracting structured information from language models, and doing summarization. And all of these followed pretty similar patterns in terms of how these building blocks were constructed and put together and what different prompts were used and stuff like that. So we put a lot of those chains, as we called them, into the core library and kind of went from there. So this is an overview of what's in LangChain, and just to highlight some of the value props that these provide. A natural question that we get a lot is why build LangChain, or why build with LangChain, and why use LangChain? And I think there are a few that we want to highlight. Probably the main one is just speed of getting started. So we have a lot of these building blocks with standard interfaces, and that gets a little bit to the next point, but we also have these chains, and those combine these building blocks into ways that people often like to combine them. And so we've found people able to build question answering applications over their own data in like 20 lines of code or something like that. There's a lot of happy paths to get started really easily. And this is also due a lot to the interoperability that we have between different pieces. So no matter what model provider you're using, no matter what embedding provider you're using, no matter what vector store you're using, they all have the same interface. So it makes it really easy for people to bring their own or write their own. So if people are using a custom model or a custom vector store, you can pretty easily write a custom wrapper and swap it out. And this gets to the second part around customizability, or the third part around customizability. You can swap in these pieces, including the prompts themselves. So this is a big part because we often see that people want prompts or responses that are specific to their application or specific to their use case. So they might want the language model to respond in a particular way or take certain things into account. And so we make it really easy to swap those things out. And then the fourth major value, I'd say, of building with LangChain is we have a really awesome community. And so I think there are a lot of people out there that are actively kind of like building and then contributing back to LangChain. And so there's a lot of really awesome applications that I couldn't even think of that now have big parts of them kind of like contributed back to the core library, and that kind of feeds back into the speed of getting started again with things. So that's a bit about the library. I'm sure we're going to jump into some more exciting stuff now and talk about some specifics.
Yes, for sure. And we're going to dive into all of the code examples and kind of helping people get started. So some of the boilerplate, so to speak, to get rolling with LangChain. Before I jump off and start to talk a little bit about the Redis side of this, you touched on this a little bit, but I kind of want to get a sense for like what was the core motivation for the project, like that, but also like when did you realize this was taking off and it wasn't just a like fun side project anymore?
Yeah, so the core motivation was definitely kind of just trying to abstract away a lot of common patterns that I saw. It really wasn't kind of anything more than that. It was something that I started on the side for fun, had been talking to a bunch of folks, saw these common abstractions, patterns, put them in a library, read a few papers that kind of like contributed to this idea of some common abstractions and put them in there and went from there. I think probably after like a month, I knew there was something kind of like really exciting here. And I think, there's a few things that kind of like impacted that. One was, the response that it got and the people that were interested in it. But I think another like really important thing there was it wasn't just people in data science and machine learning that were interested in this. And that's kind of what, my background's in machine learning. That's what I had anticipated a little bit. I initially thought of it as kind of like a machine learning tool or something like that. But there was a lot of interest from kind of like web developers and people getting started. And I think that makes a lot of sense because now you think about these language models. Previously, to do machine learning or AI, you probably needed to train your own models. You needed to have your own kind of like hardware to run them, stuff like that. Now you can just call out to an API, and these language models are really, really good at zero-shot learning. So just doing things from scratch, and that makes it really easy to start building applications from scratch. And so we got a lot of application developers interested, and that contributed in a large part to the TypeScript library that we released a few months after. There are a lot of developers that don't use Python. Python's very big in the data science and ML communities, and that's why we started there. I also only know Python. I don't really know TypeScript, but now there are a lot of people in the community that are full stack web developers and want to use this technology, and it's now extremely easy to because they're behind APIs, and so we ported over a lot of the same ideas into a TypeScript library.
Yeah, and to sort of summarize, it almost sounds like because of all the advancements in the space, like the bar to get started has come way down, which is great because now all of a sudden we have a multidisciplinary sort of cohort across the stack from a technical perspective, but then also even getting into these different verticals, like vertical specific applications. And some of those developers and some of those project contributors are now able to jump right into something like LangChain and help to start to build.
100%. And honestly, you go back to original motivations. That's part of the reason I started open source as well. I'd never done anything open source. I wanted to work with a bunch of folks in the community and meet a bunch of different folks. And yeah, I've definitely met a lot more awesome folks than I could have ever imagined.
Awesome.
Yourself included, Tyler.
Thank you. Well, hey, look, we are really excited to have you here. We got some good insights from you. I'm going to turn the page a little bit, and we're going to talk a little bit about Redis. And so why Redis is kind of getting a lot of traction right now in this large language model space. And before we dive into all the code examples and use cases, I'm going to set the stage a little bit. So just to get a little bit deeper into the Redis side of things, we started with this open source core that has always been kind of a part of our ecosystem for almost 15 years now. It's got a core set of data structures which allow developers to easily store and retrieve data. And we've extended this in the past couple of years by adding support for things like JSON and even probabilistic data structures such as Bloom filters. And in addition to that, we continue to invest heavily into developer ergonomics. So what does that mean? It means that we want to make it easier for you, the developer, to build applications that can take advantage of all of the capabilities of Redis. And so that means offering supported client libraries in pretty much every language. Almost every open source language you can think of, Redis has some kind of integration or some kind of library, or even an OM library. And so this means we're able to get you closer and closer to the data and let you work with the capabilities. It also means that we're offering a companion desktop application called Redis Insight. This is free to use as well. And it helps the developers use and interact with the database and see how it's all working with their application. And then next, we're also extending the capabilities of Redis even further. So we're adding layers on top that introduce things like event streaming or even integration capabilities with other databases so that as data is changing in that system, you can ingest it into the Redis platform as needed. We've also introduced query and search capabilities to allow you to inspect some of these hashes or JSON data within Redis. You can define the secondary indices, which allow you to move beyond Redis as just a simple key value store. And we've also introduced server-side functions, so you can interact with your data within Redis in a variety of ways programmatically. So the goal here is just to make it easier to use and to sort of extend the set of use cases that it can work with. And so lastly, to sort of fulfill the requirements of enterprise organizations, we took a stab at trying to implement things like linear scalability and high availability and durability so you will never lose data, or even tiered memory access so that you don't have to use RAM for everything. It can work kind of specific to your use case. And that's what bundles up into the Redis Enterprise product. But this is a little bit of that journey of how we got there, and it's all been focused around the developer. So one of the new areas that we've spent a lot of time investing in recently has been Redis as a vector database. And this is partially because there are a lot of tools that are coming out right now to help accelerate and boost performance of large language models in production. But this is one of the hottest ones. And it's just one of the many areas Redis has started to invest in. But as you can see, a number of technologists and thought leaders and even investors have identified this as a fundamentally groundbreaking tool in the AI wave. And so we're going to talk about what that means, but it all starts with this. Redis offers the capability directly within our database. And this is something that a lot of people still even today don't know. They think of Redis as a cache, which to be fair, it is. But not only do you get the familiarity of working with what's become sort of a staple in the real-time data world, but now you can store your unstructured data here in Redis as embeddings. And so keep in mind, just kind of to, again, level set, embeddings or vectors are numeric representations or a list of numbers that encode meaning and context. And these are impressions, often from an AI or machine learning model, on a piece of data. And so when used together and combined, we can actually perform what we call semantic search for discovering similar or relevant pieces of data compared to some input. So this is going to play out to be incredibly valuable in the large language model space, and we're going to explore why. But a few other important properties of a vector database. This is an externalized knowledge base that's been loaded with your domain-specific or even unstructured data, and it's all been encoded as vectors or embeddings. A vector database needs to support real-time CRUD operations so that as your system changes, as data changes, it needs to be able to make those updates to the index and to the underlying records in real time. It also needs to manage an index so that you can, as a developer, perform efficient search without having to worry about managing some kind of external index structure. This opens up a whole host of use cases for some really traditional pieces of technology, things like recommendation systems, document or information retrieval. But we're really excited about some of the work that you can do with a large language model. And so I just want to briefly touch on, there's a lot of different vector databases and solutions out there, and some of them might be right for you. Some of the winning traits that we've seen in this space include things like low latency, enterprise readiness, especially if you're working with certain kinds of data or have certain end users that have different expectations, and also community trust and community familiarity. And so we have a lot of performance improvements and features that are coming down the roadmap and onboarding material even that's on the way. But we just want to let you know that Redis is definitely one of the great solutions here. To wrap up this overview with Redis as a vector database and some of its use cases, just wanted to highlight the current state of features and integrations. So out of the box, we offer 2 vector indexing methods, including flat for a brute force style approach and HNSW for a faster but approximate search. There's a couple different distance metrics, and these are sort of the mathematical underpinnings of what make similarity or semantic search possible, and these are going to be relevant to your use case and your data. You'll have the ability to choose. And then, of course, we have 3 different search methods. One is a traditional KNN, ANN kind of approach, where you can select what are the top K most relevant texts or images to my input. Another one is with hybrid filtering, where you can use some of the existing search and query features, including filters, for example, numeric filters or tag filters or even text search, to combine that with vector search and make it more powerful. Lastly, we also have a bunch of ecosystem integrations. One, obviously here, for example, to call out is LangChain, and we're about to dive right into that. But this is just a good overview of where we are today. And that's a perfect segue into the better together story. And this is where Redis and LangChain can bring together the best of app development experience and also backend performance and extensibility. So I'm going to talk about a couple different use cases that you can use a vector database like Redis to also improve the large language models in production. And I've asked Hutcherson to kind of hop back in, and he's going to help acquaint us with the LangChain code examples. So we're going to jump right in.
Thanks, Tyler. Yeah, so this is the setup for both a language model, which is going to be used in basically every LangChain app, and then Redis, which will be used in a lot of the apps, especially the ones that we'll see coming up. So we can see here that first we have some quick install. This is with the Python package, although it's also doable in the JavaScript package. And we can see on the left, we're working with the language model. And so you've got the language model. We use OpenAI for this, although there are 15 or so different language model providers. And then you can see that there's a pretty simple way to call the language model. You can pass in a string, and so there's 2 calls in the code snippets here, and this is just to demonstrate stuff that the language model out of the box might be good for and what it might be bad for. So the first query, it will have no problem answering because it's generalized knowledge that it's been trained on and it knows the answer to. The second query, which customers recently purchased faulty refrigerators with an electrical problem, is a very data-specific question. It's related to some underlying database that the language model has not been trained on, and it currently does not have access to at all. And so the language model will simply hallucinate something here. So that's the setup of the LLM. Now let's go over to Redis. And so Tyler and co at Redis have written an amazing wrapper which abstracts away all of the kind of like difficult parts and really interesting parts that you just saw him talk about, and it makes it really easy to set up. So you can see here that we do Redis.fromText. We pass in a list of texts. We passed in an embedding model, and this will create the embedding that's used for semantic search. And then we pass in 2 Redis variables, which are used for the index name and the URL. And that's it. We've now got a vector store, which we can continue to add text to over time. And so that's what the next line is. And then we can now use this vector store natively within a lot of the LangChain chains, specifically to do the fetching and retrieval part.
Absolutely. So this is a perfect setup. This is some of the boilerplate, as Hutcherson mentioned, you're going to need throughout building all these different examples we're going to show you. So the first one is all about context retrieval. So keep in mind, especially for those of you who are not super familiar with language models, these models take text as input and then provide you some text as output. And this comes down to sort of a subset of this field we call prompt engineering. And prompt engineering is kind of taking off in its own way. There's a lot of people that have opinions about it, but there are even jobs, right, being created now called prompt engineers. Don't believe me? Go look this up on Google right now. So the first case, like I said, context retrieval. We need to structure the input to this model to make sure that it can actually perform the task or give you the answer that you're looking for. And in this particular example, I took Wikipedia articles. This is just an example. You could imagine it's your sort of domain-specific proprietary data set. But I took Wikipedia articles and I chunked them up. I broke them up into pieces. I created embeddings and I stored them in Redis. And that's kind of what we just saw with the LangChain wrapper in the last example. But this enables a process now by which your application can query the vector database, in this case Redis, for the top K most relevant pieces or sources of information from these articles. that can help answer the question or interact with the user's query. Now, in this example, the user is asking about the Summer Olympics. This data set has a lot of information about the Summer Olympics from these Wikipedia articles encoded and stored in Redis. And when I perform that search, I can now retrieve those sections of text that are most relevant. And then that gets piped all the way over to the prompt. So we insert the question, we insert the context that we just pulled from Redis, and we kind of frame it. And we tell the model, hey, look at this context. See if you can answer the user's question based on the context I've provided you below. And if you can't do it, then just say, I don't know. What we've done there is we've actually provided a little bit of structure, a little bit of guardrails on the model so that it's not going to make something up. This is an effort to try to improve the quality and also make sure we don't hallucinate or make anything up. So that's the sort of overview of this use case. I've also provided a link to an example that does this. There's a GitHub link on the bottom right of your screen. Definitely take a look at that project and see if you can learn a thing or two. So I'm going to hand it back to Harrison, who's going to talk about how we would implement this in LangChain.
Yeah, so that was a great overview, and the code snippets here show exactly how to do that. So we'll import a chain called Retrieval QA, Retrieval Question Answering, which is designed to do exactly the flow that Tyler just described. So we'll do a retrieval step to fetch relevant documents, and then it will do question answering over those documents. So we can see that first, we create our retriever, and we just use the vector store as a retriever. This will, by default, use semantic similarity under the hood. We can pass in different kwargs to use different methods. So we can do other methods like max marginal relevance or things like that. We can also pass in filters to do some of the hybrid search that Tyler was talking about. But we'll set up our retriever, and then we pass it into this chain. So we pass in the LLM, which we constructed before, the chain type, which is stuff, and there's a few different chain types that you can use. But the stuff one basically puts all the context into one prompt and sends it to the language model. And that can be good because that can be really good when you've only got a few documents that are smallish in size and you want to only make a single call to the language model. But there can often be many documents or larger documents, and so for that we have other chain types which we have documentation for on the site to basically see which one might be better for your need. We then pass in the retriever, and then we'll also pass in return source documents true, which just is a nice way of highlighting which documents were actually used to answer the question. And so this can be really useful in applications as well, just to provide confidence that the answer provided is correct, or allow the user to click into and see what exactly is going on. And so that's setting up the chain, and then running it is really simple. We just call chain.run. We can pass in the query, which is the question about the Summer Olympics, and then we can get back and look at a result, and then also the source documents.
Awesome. That is a great overview as well. Like you can see, everybody, this is something you can do in very few lines of code, so the developer ergonomics are incredible. It's really easy to build these applications with LangChain. The second use case that we're going to talk about is caching. There's a couple different forms of caching I want to highlight, but this is something that Redis has been doing since the beginning of its story as a database. Redis is a cache, Redis is many other things, but it is a cache. And when it comes to large language models, we're talking about natural language inputs, so some kind of text, some kind of question or information. And a semantic cache that's built on a vector database like Redis can actually register a hit on a question or a query that is similar or relevant to that of another user's question in the system. So talking about scale, this is how Redis Enterprise is used across Fortune 100 companies today, and that's going to remain the case in this new AI wave. And this particular capability of semantic caching is incredibly useful for when you have a large user base, or maybe you have commonly asked or repetitive questions, especially ones that have known answers. That way you can save yourself a little bit of time and money not having to fully invoke the full extent of the language model sitting on the other side. So all in all, this technique is here to reduce application costs and overall system throughput and latency. So we've got an example here prepared for you, and I'm going to hand it back to Harrison to show how this works.
So again, we've got a few lines of code here, and so we've got a standard cache and then the semantic cache, which Tyler was talking about. And so on the left, we can see the standard cache. And so this will do an exact match based on the string. And so we can see that if we were to run this the first time we called the LLM, it would actually call the LLM and then return the answer. And then the second time we'd call it, it would find the hit in the cache and return that. On the right, we've now got this really interesting semantic cache, which I think Tyler first introduced me to, and it's a really cool idea. And so basically, yeah, you initialize the LLM cache, and you just do langchain.llm cache, similar to how you do with the standard cache, and then you've got this Redis semantic cache, which you can create with just a URL and then an embedding model, and then below we can see we call the LLM with tell me a joke, and then we call it again with tell me one joke, which is different. It's not the exact same string, but it's semantically the same thing. And so we can find, and so if we were to run this, we'd see that it would find that in the cache and return this. And there's different parameters you can use to tune it, to adjust kind of like, how exactly similar they have to be. But as Tyler mentioned, this is a really cool idea that can dramatically reduce costs and latency and overall kind of like make the application more production ready and usable.
Yeah, exactly. And, we're actually at the end of our time here, folks. And, just as a opportunity to kind of wrap this up and summarize it, hopefully what you've seen here is actually an encouraging thing. It's an encouraging thing to keep building and to keep knocking in this space. And it can even be as simple as a few lines of code with a tool like LangChain to get started. And while there are a ton of challenges and legitimate concerns still with using large language models in productions, especially for enterprises, merging tools like LangChain and battle-tested backends like Redis can provide you with a ton of success in overcoming some of those challenges. So to close this out, we wanted to get a little bit more insight from Harrison while he's here and willing to share. And so I know something that I'm curious about as a developer and also other community members, like what's new and what's coming down the pipe with LangChain? What are you willing to share with us?
Yeah, there's well, I think the thing about this field is it's so new and it's moving so fast that honestly it changes week by week. So I think, I don't know if I have an amazing answer for this, but I think one of the big things that we're focused on is going from prototyping to production, because we do see a lot of people starting to build more with these applications in hackathons and kind of like personal projects, but we really want to focus on what does it take to put them into production. And this is where I think a lot of the stuff that we talked about, some of the semantic caching or just caching in general, and also just the production readiness of Redis are useful as people start to move to production. There's a lot of stuff we need and want to do on the LangChain side as well, but we're really hopeful that now is kind of like the time to start thinking about going from prototype to production, and so we'll be introducing a bunch of features around that.
Awesome. And secondly, and also lastly, I also wanted to get your take on advice for getting started in this field. As you mentioned, it's so new. This is something that's now been around truly for a couple months, where people have been working and using this kind of tech. So what's your advice to a new developer, maybe coming out of college or even in high school still, or someone later in life who wants to get into this space? How should they get started?
Honestly, just start building. Like I think as we talked about, the barrier to getting started to building is pretty low, and as we also talked about, it's so new. And so I think if you start building, it'll be a pretty quick ramp up, but then you'll pretty quickly develop, in the grand scheme of things, a decent amount of expertise. And so I've heard a few people I really, really do believe that it's still kind of like day zero in this LLM kind of like application building experience. And so now is absolutely the time to kind of like just start building. There are so many things that are not known how to do. There are so many existing issues, but it's really easy to get to a point where you start building and quickly run into those issues. And then you're in a much better place to solve them when new stuff comes out, realize how important it is and incorporate it. I just think it's a really, really exciting time to be building in general.
Absolutely. And that's a great sort of segue or cue to sort of our call to action for all of you watching. We've included 2 links here. One is a link to the LangChain documentation where you can see all of these great features and many more to get involved. And there's a link here specifically to the ecosystem page for Redis. This will show you a bunch of the different capabilities, including the vector database, the retriever, the different caching implementations, and even some things we didn't really get to talk about, including conversation memory and things like that. There's also a link here to a GitHub project that we've been working on, where we've been taking a Q&A, a question answering application using OpenAI, Redis, and also LangChain now as the sort of application development layer. And this is an end-to-end Streamlit app, so you can see how to get started. So folks, that's it for today. We wanted to thank you for joining. Harrison, thank you again for being here.
No, thank you guys for having me. This is awesome, and yeah, it's an exciting time. So happy to be here.
Awesome. All right, take care, everyone. Thank you.
Thanks, Tyler and Harrison. It's amazing to see technologies that were recently only accessible for AI specialists and ML engineers are now packaged, offered as a service, and become available to any developer. Meanwhile, Redis is growing quickly to become a standard data layer for powering vector databases and vector similarity search use cases.